1, 2, 3. Alright, so this is the Allen Bradley 1756 chassis PLC. So as we can see here, this is the power supply. This is the actual PLC. You can see it says Logix 5561 there. You may not be able to read it real well on the video, but that's the model number of the PLC. And then we have 6 input cards. So this is a 7-slot chassis. These come in 4, 7, 9, or I think 10 and 17 slot chassis. Okay, so there's several different chassis depending on how many input and output cards that you're going to need. This is a 7-slot chassis. Now notice the slots count: slot 0, slot 1, 2, 3, 4, 5, and 6. So as we go into the software, you'll see that. So now the first thing we're going to have to do, as you can see, it's already powered up. You can see the lights flashing. So it's already powered up. But what we need to do is plug in the Cat 5 cable. This is our network cable. We're going to plug this in. There's actually 2 ports on this particular card. Not all of them have 2 ports, but we want to just put this in there. And you should hear that click when it goes in. So there's a little tab on here. There's a little plastic tab on this, the RJ45 connector, and you need to press that tab in to remove it. Okay, when you're pressing it in, you don't have to hold the tab in, you just press it and that'll push down automatically and click when it locks in. That's what holds it in. And then don't yank these out. When you take them out, make sure you press in that little tab and it'll slide right back out. Okay, you don't have to remove power to plug in a network cable. Then what we're going to do is we're going to plug in to the little blue hubs or switches. Actually, they're switches here on the counter, and you see a light there flashing. Okay, and you see the link light up here flashing. Okay, that is referred to as the link light. If that is flashing, then that tells you that you have network connection. All right. If you do not get a link light, then there's probably something wrong with your cable, or maybe the switch isn't powered or something like that, but you should see that flashing link light. Right. Another thing you'll kind of notice on this, when it on this particular card, it will tell you the IP address. So as it scrolls by there, it's telling you it's 110.101.201.167. So you can actually see that on this particular network card. Unfortunately, not all the network cards will do that, but this one does, and that makes it kind of nice. All right. So this PLC we already have pre-wired up to a panel here with some indicator lights and some various switches. Okay, and the IP address is actually listed on the top of that also. So you'll see there the IP address of the PLC is put on a label there for you so you have no doubt what the IP address should be. All right, so to use this, we need to start RS links. Okay, so if we hit like the Windows key, so if we come along and we press the Windows key and pop up the search, okay, or actually we're just clicking the search bar, either way, and then we just type RSL, and when you just type RSL, you'll see several different apps pop up, but the first thing we need to do is press the RS links. This is the communication package. So we click on that and it's going to load up. Looks a little silly right now with the multiple screens, but as we open this up, now the first thing we're going to do is we're going to come up to communications, configure drivers, and we're going to use an Ethernet driver. Okay, So they also have an Ethernet IP, but Ethernet IP requires you to be on the same subnet. And so we're just going to use Ethernet. And I always just like to name this PLC underscore network. So they're asking for a name here. They give you some kind of default name. I never like default names. You want to give it a name that means something more descriptive to you. So now we're going to come in here. We're going to put that IP address in that we saw. So it's 10.101.201.167. So that was the IP address. Now, if we had multiple PLCs we wanted to talk to, you could go ahead and just list those on here. And just list each one of those on the screen here. And then they'll pair. So you see when I click that, you can see the PLC network popped up over here in the tree window. And if I come over here and click the plus sign, you'll see it expand now. You'll see the 167, which is the PLC that we just looked at. And you see I also threw in a 165 IP address. That's another PLC, but it's not currently on the network, so it's showing unrecognized because it's not powered up and connected on the network. But if it was, we would see it there and be able to select it. Now, if you hit this plus sign for our PLC, the 167 PLC, you'll see it expand there. You'll see 00, as I talked before, that's your first slot. So your first slot, in this case, it has a 1756, that's the chassis number, dash L61, which is the Logix 5561 PLC, which we saw in slot 0. So remember, these count starting at slot 0. Slot 1, on the other hand, is a 1756-EN2TR. All right, that's the model number for the Ethernet card. So again, if we look here at our cards, we'll see that the first slot is the Ethernet. The next card is a 1756 IF16, which is a 16 input. I is actually for insulated, so there's 16 insulated inputs for this card for analog inputs. The third slot is for 1756 OF6CI. Okay, that notice the up here, I'm sorry, this I up here was IF. This I before the F was actually an input card. Okay, so that's telling us it's analog inputs. Okay, this card is OF6C. So that's OF, that O indicates output. So IF indicates an input. The O stands for output. So this is an output card. The C indicates that it's a current card. So it'll give us a 4 to 20 milliamp or 0 to 20 milliamp current output that we can then send to an actuator. So again, this first I here indicates that it's an input card. This O indicates it's an output card. All right, but this OF6C, so that tells us it's got 6 output channels, and the C indicates their current, and the I, the last I here before the slash A, indicates it's isolated. Each one of these 6 current outputs are isolated, so they're not sharing like a common ground with another input. So each one has their own isolated positive and negative terminals. They're isolated from the other 5 channels on that card. So that's what that trailing I. And then slash A is just like the revision version number of the card. Okay. IB, the next one, IB16D. Okay, so that is a DC input. So again, the I indicates after the dash indicates I for input, and here it actually tells you that these are DC inputs. So these are 24 volt DC input card. The next card is OB8E. Okay, And so that's a DC output card. So we have a IB is a DC input card, OB is a DC output card. Right? And so we can see all of these here inside of the RS Links software. And then finally, the last card then is an OW16I. So again, the O means it's an output. This is actually a relay card. So these are relays, so we could wire up various different, like 120 volts AC to this relay card, or we could wire up, 24 volts DC or 5 volts DC, whatever. And then we would, these are relays and they can connect there. Now, obviously, you can't do like a high power, like 480 volts to this relay. You want to check the manual and see what the rated voltage is and what the wiring is on these. But the O, again, the O stands for output. There's 16, tells us there's actually 16 relays on this card, and the trailing I tells us that, again, it's isolated. So these relays are all isolated from each other. All right, so not all cards, they also make like OW16s, but without the I, which means that they would not be isolated. So they would share either like a common voltage source across usually 4 relays within the card, or things like that. But the I indicates that these are insulated. And so the wiring would be different for these for one that was just a OW16 without the I. All right, so the nice thing about this, the RS Links, again, is the communication software. It's allowing our PC to talk to the PLC. And so we can see here we don't have a red X for the 167 IP, so we know that, hey, we're communicating with it. And we can also, it also, since it's communicating, it's asking here, hey, what is my IP address? Or not what is my IP address, sorry. What is my, what card do you have in slot 1? What card do you have in slot 2? And so the PLC is sending all that information back to us. We can see that information right here inside of RS Links. Okay. Now we can look at like the IP address if we right click on the network card here. Okay. For some reason that one's not coming up. Like if I right click on the DC input card, you can see here it has like device properties, and we can come in here and see that. Normally I can do that on the Ethernet card too, but for some reason this one's not letting me click on that. It's not responding, so I'm not quite sure. Maybe it's just the model, the version number of that card. So, but a lot of the cards we can actually right click on them, come up to device properties, and sometimes there'll be configuration changes that we can make in there. Like a lot of times you could right click on it and change the IP address. But like I say, for some reason, not letting me do it on this one. Okay. So once we've established communications, we can then create a program. So I'm going to come over here to RS, and I'm going to type in like RSLOG, and you can see it brings up the RS Logix 5000 application. So I'm going to go ahead and start that so I can create a program, and it's telling me that this has not been activated yet, but it should go ahead and start once I click OK there. Takes a little while to start up. See if give it a few seconds here. All right, so you see this icon here popped up. It took it a little while. It does take it a little while, but I think it took even longer because we're trying to record this, and that's slowing down my whole computer. All right, so when we come in here, we can, if we have an existing program, we could open that. Okay, I'm just going to close that, and I'm going to come up to File, New. Okay. And right here, you notice here, it gives us a 1756L55 controller. All right, well, go back to RS Links and look. This particular PLC is not an L55, it's an L61. You see that number right there, L61. So we got to use that. We've got to make sure that when we create our program, the program is going to be set and created properly for your version of controller. So you have to click down on this and select the controller that matches the version you need. The next thing we need to do is, now we've matched the controllers, we've got to match it to the firmware version on the PLC. So if we don't know that, okay, we can come over here, right click on this, and go to Device Properties, and it tells you that it's revision 16.022. So you can see it's revision 16. So again, using the RS Link software, we can find out this information if we don't know it already. So we're going to come over here and I'm going to select revision 16, and then now we need to give it a name. Okay, well, you need to be very careful when you name these that number one, don't use any special characters. All right, so you just want to give it a basic name. So I'm going to call this Seal-In Circuit. Okay, and I don't like to use spaces or anything in the names. Okay. And then here you could give it a longer description. This is my first seal-in circuit. Still getting that activation error. First seal-in circuit on a control Logix PLC. All right, and you can give it that. And then down here you can see the chassis. Okay, so as I mentioned before, 1756 is the base chassis number for these type of PLCs. So when you're buying like an I/O card or whatever, you need to understand this is a 1756 chassis. Once you do that, then we also have to tell it how many slots we have. So again, these are your choices. You have a 4, 7, 10, 13, 17 slot chassis, and there's also kind of a special 5-slot XT chassis. I've never actually seen one of those, but we have, in our case, the 7-slot, and then we have to tell it where the PLC itself is. Well, the PLC is in slot 0. Again, how do we know for sure? Well, remember, they start counting from 0, so we could just simply look at the PLC, or we can come over here to the RS Links and we can verify which slot the PLC is in. Now, here's the catch. We don't want to put this on the C drive, okay? So what we want to do is we want to come over here, we want to browse, scroll down, and put it on the D drive. So I'm going to hit the D drive here, okay, and say OK. And you may actually want to create a folder on the D drive to put this in. So I've actually have created a folder with my name, or at least partial of my name, and so I'm going to put that in that directory. All right. And so then once we've selected that, we'll say OK. It'll kind of go to thinking here for a few seconds, and then it will pull up the interface. Okay. All right, so now it's pulled up the interface. Now let's say that we got the controller wrong. If you double click on this, you can come in here and you can actually click on the change controller button and correct it at a later time. And actually, if you don't know you have it wrong and you try to download, it will actually come up and say, hey, you know, this doesn't match the controller you're trying to download me to. Do you want me to change it? And it'll kind of change it for you. All right, so now this is kind of the way you read mystery novels. I don't know if you're really into reading mystery novels, but the way you read a mystery novel, if you've never done it, is you flip to the back and you find out who did it, right? So that's kind of the way this works. Over here we have the controller browser window. It shows us lots of different stuff over here on the left side. And what we want to do is jump to the end, right? So just like a mystery novel, we're going to jump to the end and it says I/O configuration. So what we need to do here is we need to add our I/O cards. Now, we've got 6 input and output cards, as you've seen. We don't actually have to add the Ethernet IP card unless you're actually going to do Ethernet IP network communications between one PLC to another. If you are going to do that, you would have to add that card. I'm not going to do that in this example, so I don't need that card. I'm not going to do any analog inputs or outputs, so I don't need those cards. Now, if you wanted to, it would probably be proper to go in and add all 6 cards. But again, if you're going to create a program that doesn't use all 6 cards, you don't have to spend the time adding them. I mean, in general, you wouldn't have bought the card if you're not going to use it, so you would want to add it. But in the classroom here, if you only need a relay output card and you only need a digital input card, then you don't need to add the other cards in here. So only if you're going to use it within your program. But what we want to do here is we want to come on I/O configuration. I'm going to right click and I'm going to add a new module. Now notice, according to this program here, we've told this program that we have a 1756 L61 controller. So we told it we're using a Control Logix chassis with the L61 controller. But what we're doing with this program here, this RS Logix 5000 is creating a program. At this point, the RS Logix program has never talked to the PLC. Yeah, over here we've opened RS links and we established communications with RS links. But at this point, we have not told the PC what our PLC is or made any communication. So even though the RS Links program is communicating, at this point the RS Logix 5000 is not communicating with the PLC. So it doesn't know what cards we have. And that's why we have to come over here and tell it what cards we have and we're going to use. So we click on New Module. And then you select, if you know you want to add your analog card, you come over here, here's all your analog cards, and you can see the model numbers. Again, if you don't remember the model number, you can flip back to the RS links and find those. So again, I'm just going to use the DC input for right now. So I'm going to use the 1756 IB16D card. So that's not an analog, that's a digital. So 1756 IB16D, right? That's the card I have, IB16D. So I'm going to add that. All right, so I select that card and I click OK. And now it wants to know what the revision number is, and you know, hopefully it's the newest revision, so you want to select that. Okay. If it's wrong, it won't work. Okay, but for us, you want to use that. Now we got to give this a name, so this is just going to be DC inputs, and we got to tell it which slot number. Now notice it defaulted to slot 1, but actually this card is in slot 4, so you've got to select the correct slot. If you don't assign it to the correct slot, it will fail and give a fault. So the controller will go into a fault mode. The other thing is they have this thing called keying. The idea is keying is kind of, if you're replacing a card with another card, you want to make sure that the keying match. However, if everything's not 100% correct, you will run into some errors. So what we want to do in the classroom here is we're just going to disable keying. Okay, so you want to set your slot number. You put in the name. You can add a description if you want, but it's not that important for the class. But put in the slot number, disable keying, and click OK. All right. Now, if you need to change it, like you forgot what your slot number was or whatever, you can always come over. Notice now that that card in slot 4 is over here. You can always just double click on this and you can adjust the slot number if you had it incorrect. One thing though you got to notice is if you had this assigned to 4 and then you wanted to assign it to 5, but you already assigned something else to 5, you have to kind of swap them around because it won't let you add 2 5s simultaneously. All right, so then we're going to add the relay card. So I done forgot the relay card, so I'm going to double check here. Yeah, the relay card is in slot 6, and it's an OW16i. So I'm going to come back over here to I/O configuration, right-click new module. Digital, relay modules are digital, and OW is going to be down near the bottom. So it's a OW16i, and I'm going to select that. Take the revision number, and that was slot 6. And I'll just name this relays. And again, I'm just going to disable keying. And then there's other configuration stuff that you can go in here, but for a standard ladder logic program, usually we don't need to mess with anything else for digital input or output cards. All right, so once we've done that, we're going to come up here and create some program tags. All right. Now, there's actually, if you see up here, there's something called controller tags, and then under main program is something called program tags. A tag is kind of like a variable name. We can assign a name to any output that we want to use, any input we want to use, or any memory locations that we want to store data in. All right, so we can create these tags anywhere that you want. But if you create the tags under controller tags, those are global. So notice here this tab is called tasks. And then there's a main task, and under the main task is a main program, and then you know, I mean, just by the name of that, it implies you can have multiple programs, right? So you can have multiple programs within the main task, and then, you know, you could right click on here and you could create multiple tasks. If you create a tag inside of controller tags, it'll be available to all your programs inside of all your tasks. If you create your tags inside the program tags, they're only going to be, those names are only going to be available to the programs inside the main task or inside the main program. So I recommend that you don't go wild and throw all kinds of different names up here in controller tags. This is only for some very dedicated tags that you want to be accessible. You want them to be accessible through all tasks, through all programs. That's where you would put those up here. So we're just going to create our tags under program tags. So if we double click on this, it'll pop it open. Now notice down here at the bottom it says monitor tags and edit tags. All right, well, I don't know why it always defaults to monitoring the tags even though we have yet to create any tags. So the first thing we're going to do is click over here on edit tags. And one of the things I want to point out to you here on this software is you want to slide these here. This here we'll be using when we get to the ladder logic, and it gives you different options. But they make this so small here. You really want to extend this all the way over so that you can see all the different tabs under there. And the same thing here, when you're doing your names and stuff, you want to widen these up so that you can see them. Okay, they have like a description field and a name. So the name is the tag. The tag allows us to just create a name. So I'm going to create like a start. All right. Now the start is going to be my green button. So my green button is my input. Remember, I is for input. Card 4 is my input card. And then we want to go to data, and bit 1 of my DC input card is wired to the green start button. Okay. So bit 1 is wired to the green start button. Okay, bit 0 is wired to the red stop button. So I'm going to, next one I'll create is a stop. So notice here it's local, LOCAL, colon, bit 4, colon, I for input, dot, data, dot, and then the stop is a 0. Okay. So you can actually type these in. Now this is real nice when you're doing a lot of these, because you can just copy and paste this and then tag on the number. It's much, much faster than clicking on the down arrow, finding the card, hitting the plus sign, finding the data, and choosing the bit. Okay, so again, once you do one, the rest of them you can just like copy. I copy everything but the number there, and then you can paste in the numbers. So like the select bit, the first selector switch is going to be selector switch 1-2 is the way it's labeled on the PLC. And then it's going to be bit 2. All right, and so on. And we can just copy and paste these in there. If you're going to do the relay out, so I want like my red light on the relay is relays are 6, colon, their outputs, dot data, the red light is 0. So again, I'm going to highlight everything but the bit 0, and then I can do the green light. Okay, and I'm going to put the green light in there, and it's bit 1, and so on. And they're labeled on the PLC, so you can see those. All right, so you can see the different lights on the PLC. All right, so now once we've created some tags, now you may also want to create like a virtual bit. Okay, so I'm going to create a virtual bit here just to show you the difference. Notice these aliases. The word local means that it's local to this card. So local is referring to a card in one of the slots in the PLC. And so these aliases here are pointing to physical wired up inputs or outputs. Okay, so the alias is referring to a physical input or output that we physically have wired up somewhere. Now, if we're actually using something like Ethernet IP or DeviceNet or whatever, and we're getting information from across the network, it would say remote here. All right, but when we're creating a virtual bit means it's inside the PLC, so there is no alias. And then if we're doing a bit, we need a Boolean tag. Boolean just means 1 bit. Okay, so we set, now notice I didn't have to set that on the ones that had aliases, because I did set it by selecting 1 bit in there. All right, each one of these are switches or lights, and so they're 1 bit. And so by simply selecting them, it set that information. But now when I do a virtual bit, I have to tell it what the data type is. Okay, and again, I can come in here and I could add descriptions. This is virtual bit, okay, stored only in memory inside the PLC. So, normally you'll have some kind of description relating to what you're doing with this. And again, you can widen these so you can read more of it. All right. You definitely want to widen the name some if your names get longer, and the alias. You want to see the whole alias. You don't want it to be like chopped off like this where you can't see it. All right. So make sure that you slide these out so that you can read all of this information. The description isn't as important, but it can be very nice. All right, so now I'm going to come over, now that I have my tags, I'm going to go to main routine, and now I can come over here and I can like drop down, and I'm going to create, here's going to be my stop bit, and then I'm going to drag down another one, and that's going to be my start. Notice that I already created the tags, and so it automatically labels there then the alias that those are mapped to. All right, so now I want a branch here, so I can come up here and click on that, or I can right click here and create the branch. So you can add different parts on here. So like I want to add it after that, so I'm going to click on there and add my branch. And now notice I can drag these around. You notice the green dot. So the green dot is where you could put it. Okay. And so you can drag these things around. Once you put them, click on them, hold down the mouse, and you can drag them around. Okay. You want to actually click. It depends on where you click. So if I click too high, I'm getting the green dots up here. I need the green dot on the ladder. And so you need to make sure you click on the actual contacts. Okay. You can also click on this and copy it, and then I can paste it down here, and then you can rename it if you want it to be a different tag. Now notice here, this is my virtual bit, and I gave my virtual bit a description. So that description appears right inside your ladder logic. And that's the beauty of these descriptions, because this is kind of self-documenting now, all the ladder logic. So if I would have done this with the start and stop buttons, it would have that in there. And so now I'm going to come over and I'm going to tag on a relay. And this is going to be for the red light. All right. If I want a new rung, I'm going to create a new rung. Oh, I'm sorry. That should have been the virtual bit. Okay. Remember, anytime you're doing a seal in, these have to match. Whatever this is, they have to match. All right. So now that I got my virtual bit on, then I'm going to add a rung, right click and add a rung. And then I'm going to copy this virtual bit. So when this virtual bit is a 1, I'm going to turn on my red light now. Okay. So I'm going to turn on the red light. And now I'm going to add another rung, right click, add rung. And when I turn the selector switch, so remember I had that selector switch. Okay. And if you click this down arrow, you can see all the tags you created, and I called it SS1, 2 was what I called that one. Okay, so I'm going to select that, and you can see again the local 4I data 2. All that information is there now. And so when the selector switch is closed, then I'm going to turn on the green light. All right, so that is the ladder logic. So now I want to download that to the PLC. So I'm going to click on Who Active. And up here, this little network icon, okay, that's what I clicked on. Up here where it says path. The path is the path that it's mapping down to the PLC. So we need to download this to the PLC. Right now you notice that the path is none. So there's nothing in there. So I need to put something in there. So I'm going to click on this, and I'm going to hit the plus sign, and we need to select the PLC. Remember, the PLC is in slot 0. So you had to hit the plus signs here to map all the way down to the PLC. So notice, like if I'm selected up here, upload and download is disabled. But if I select this, all right, so if you're selected anywhere else, okay, and I clicked on the unrecognized device that's trying to communicate with it, so it's going to take a few seconds. Hopefully it'll time out here. All right, so when you're on anything but an actual PLC, upload and download are grayed out. They're not available. You've got to click on the actual PLC, and then you can see you can either upload or download. All right. Now you want to be careful here. If you select upload, you're going to pull whatever program is currently running on the PLC up to your RS Logix 5000, which is going to overwrite what you're working on. All right, so normally actually in the plant, in the factory, you would want to probably upload the program so that you're uploading the most active program. But in this case, in the classroom, we want to always select download. So I'm going to go ahead and click on download here. And then it just asks me, do you really want to do this? Because if this is on, operating machinery, you can cause harm. So, always pay attention to that. But I'm just going to go ahead and select that. Now it's downloaded the program. Now notice here, it downloaded the program, but it's got the program in remote program mode. It's not actually running. So you need to look over here and see, is it running or is it in program mode? So if it's like this cyan color here, that's just programming mode. You need to click on that down arrow and select run mode, and then you say yes, change it to run mode, and it turns green. Now you're in run mode. So now, like if I come over and I press the green button, it will enable that. It turns on the light. Okay. All right. If I press, I got the start button twice. All right, so there's my mistake. I'm wondering why I'm pressing this once and it's lighting up, and when I let go, it goes off. All right, so I'm looking at my program now, and I've got the start button here twice. So I'm going to go offline. Okay, it's best if you need to make changes to your ladder logic to go offline first, and then I can click on here, and I just want to make that stop. So it should be stop and then start, correct? So now the nice thing about this is, now that I've made this change and I want to go download the update, I don't need to come over here and select all this again, okay? Don't do that. Just come over here to this little down arrow and select download, because it already knows where you're downloading it, and it's just a little bit smoother method of downloading the program. You can't accidentally click on upload and overwrite what you just fixed. All right, so and then now typically what it'll do is it'll ask you, do you want to go back to run mode, and you can say yes. All right, now if it goes into program mode, chances are it went into program mode because you had some I/O wrong or something like that. Or if it goes into fault mode, it'll do that. So if your controller faults on you, what you can do is you can double click up here at the controller and go over to major faults, and it'll show you what those faults are, and then the clear majors here button, click on that and it'll clear out that fault. You of course have to correct your program and your I/O and whatever that fault is, but it'll tell you what that fault is in this window before you clear it. So you want to make a note of it and correct your program and re-download the program. But this is how you would clear the fault. All right, so once I've created that, now notice that the stop button is already green. Okay, so the stop button here is already green because it's normally closed. The stop button is wired normally closed. And so that's why I used an open contact, because it's already wired closed. And so now when I press this, we can see that it turns on. So I pressed the green start button, the program came on. I press the stop button, it goes off. Okay. If I flip the selector switch over to the left to SS1-2, it turns on the green light. and if I flip it back, the green light goes off. All right, so there's a simple ladder logic program using the Control Logix PLC.